Greetings and welcome, friends, math fans of all ages. Today we're talking about spheres, and a sphere, this is, I love how eloquent this is, Malik and Joshua. A sphere is the set of all points in space equidistant from a given point. So that point is called the center of the sphere, and the radius of the sphere is the distance from that center to any of those points on the sphere. Now, the points on the sphere are the only points of the sphere. All right, Isaiah, make sure you're tracking with me here. The interior of the sphere is not a part of the sphere by that definition, okay? Because the inside points are closer than the distance of the radius, right? If you want to think about it that way. So that's the interior of the sphere, which when we talk about volume, of course, we'll talk about its interior, but the sphere itself is just the surface points, okay? So Lauren, it says that a chord of a sphere is a segment whose endpoints are on the sphere. So that would be like any tunnel you could dig that would pass through the Earth, as long as it comes up somewhere else on the Earth, right? That would be the length of your tunnel there. Maybe. I thought you were going to tell me you've been digging a hole through the Earth, and I was going to be excited about that. So let's see. The diameter of a sphere is a chord that contains the center. That makes sense. Right? Lots of language that just makes sense to us. As with circles, the terms radius and diameter also represent distances. The diameter is twice the radius. As with circles, the radius and diameter... Oh, duplicate. That's useless. So Malik, if a plane intersects a sphere, then the intersection is either a single point. How could that happen? Could someone visually describe to me, Isaiah, here, pay attention here. Yes, a sphere can have a plane that is tangent to it, touching at exactly one point. Okay, so it is possible, Isaiah, for a plane to intersect a sphere at a single point, and if it hits more than that, its intersection will be a circle, and if it passes through the center, then it will be called a great circle. That's the largest circle intersection possible between a plane and a sphere. All right, and the circumference of the great circle is referred to as the circumference of the sphere. And the halves of the sphere are called hemispheres, right? You've perhaps been familiar with these languages because we happen to live on a spherical planet, roughly. Oh. So, surface area of a sphere. So, ladies, gentlemen, Lauren, the surface area S of a sphere is equal to 4 pi r squared. Wow, that's like relatively simple here, right? Joshua, you with me? You guys are like kind of mumbling, murmuring. One of the ways to think about, this is not a proof, this is just like a conceptual understanding. If you think about a baseball, and if you were to unstitch the baseball, the radius of that baseball is actually larger than the radius of either of these little circles that you could think about. But this is kind of like 4 of those circles plus the scrap will equal exactly 4 circles that would have been great circles. That, once again, I do not think I would have suspected about the surface area of a sphere. That it's just equal to 4 circles that had the same radius that were equivalent to the great circle of that sphere. I don't think that is intuitive, but that's like a rough description demonstration of that, and it helps me remember it. So I think it's a great little thing. I've been using that one for like 10 years, ever since baseball existed. So, finding the surface area of spheres. what you do, you got to find the radius. There's only one dimension that's valuable to us. So if the radius is 8 and the surface area is 4 pi r squared, then the surface area, Lauren, Joshua, guys, come on now. Help me out. 4 pi r is 8, right, Malik, squared? I don't know, you seem to be like visiting friends right now. 8 squared is 64. 4 times 64, is that 256? So the surface area here is 256 pi inches squared. Now, Isaiah, I'm sure you know and agree that surface area is measured in square units, right? That's going to be, right, the amount it would take to paint the whole world, right? Right, the number of square units, Lauren, that it would take to paint the whole world. There we go. Is this 256 pi square inches. Now, here, you'll have a homework problem like this as well. Here they gave us the circumference. Circumference, remember, is equal to 2 pi r. So I'm just going to plug this in here and solve for radius. So I'll have 12 pi is equal to 2 pi r. And then you can solve for r just by using your algebra. Circumference. Distance around. All right. Interesting thing, in terms of traveling around our globe, my brother is in Southeast Asia right now for like a few weeks, and he's a younger brother, not older brother. Carl with a K, Lauren. And he's leaving Southeast Asia like at one certain time, Malik and Joshua, and then he's landing 10 minutes before he left after like an 18-something hour flight, which is a weird idea. 2 pi. Yeah. Yeah. No, he's not. He's getting away from trouble. So now I could find the surface area by just doing 4 pi r squared. So 4 pi times 6 squared. So 36. What's 36 times 4? 72, 144 pi. And this would be in feet squared. So be careful, make sure that with surface area, like once again, we're using square units and not cubic units. Yeah. 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 So, Malik, be cool here, man. So here we go, Malik. Example 2. Find the diameter of the sphere. If I know the surface area... Guys, this is just like super classic. If I know the surface area is equal to 4 pi r squared, I'm just going to plug in what I know, solve for what I don't. It's algebra, friends. So 20.25 pi is equal to 4 pi r squared. Malik, how you doing? Yeah. All right, well, don't distract the rest of us. I don't know, just making sure. Divide both sides by 4. 20.25 divided by 4. Well, I was just doing the decimal part. Yeah, the pi's are going to cancel each other out. Yeah, sorry. Yeah, I didn't. 5.0625 is equal to r squared. I feel like that's going to square root nicely for us. Root. Plus and minus. Don't forget it. R is equal to... Oh dear, I hit the wrong radical. Oh dear, I did it again. Second square root of second answer. 2.25. So that's the radius, but what did they want? Diameter. So double it. So that's going to equal 4.5 centimeters. Right? Not bad. Right, so I mean, like, these really aren't all that crazy. Here we go. Let's see if I can get my volume of a sphere demonstration working here. Here we go. Let's see, is this going to work? All right. Hi, Lauren. So, guys, check this out. A sphere. Imagine if I wanted to find the volume of a sphere, and I subdivided it into, like these slices, like orange slices, or actually maybe more like a melon. Have you guys ever like sliced up a melon, and then when you unrolled the smiley face of each slice, you then cut those as well? All right, so watch this. So that's what I'm going to do here. There's my melon slice. And then, ooh. And, ooh, oh, man. Ooh, chocolate orange. Advertising dollars. Waddy math. So, guys, each of these shapes is roughly what type of solid? Those are like pyramids. And if I calculated the number of pyramids and the height of these pyramids was r, and the number of pyramids approached infinity, I'd be able to estimate the volume of a sphere. And that's one of the things that through calculus they've been able to do. Your book has a different demonstration. I just kind of wanted you to think about how you might work your way towards getting an approximation of the volume of a sphere. All right, volume of a sphere. It's kind of a... Gentlemen, we good? We good. So here's the volume of a sphere. 4/3 pi r cubed. Once again, I only need one dimension inputted into this formula to be able to calculate it. So 4/3 pi r cubed. So definitely interesting. Yeah, your book has a pretty interesting model, but I don't feel like I need to show it to you guys. I printed it out for you as well, as far as a different type of origin of that. Malik, can you go to your seat and just stay there? Thank you. Malik, right now, please. So finding the volume of a sphere. Hey, here's a soccer ball. Actually, what are the... I bought, like, my kids a soccer ball for Christmas. I don't know what size I'm supposed to get. And what does 4 mean? Like, is that diameter? No. Right, and is that the radius in... So those are their own numbers? They just made those up? You don't think those relate to a radius somehow? Okay. All right. Well, anyways. So a 9-inch diameter soccer ball? I don't know. So if I want to find the volume of this, hey, I have the radius. The volume is going to be 4/3 pi times the 4.5 cubed. All right. As far as cubing, you are going to use the caret button on your calculator and raise it to the 3rd power is what we'll end up doing. So 4.5 cubed. What's that? Ooh. Yeah, 91. I'll write out some of these steps here just for sake of time, or for demonstration. 91.125. I'll multiply that by 4 and then divide it by 3. And I get 7.594 roughly pi is the volume. And if I multiply that by pi now, I didn't get it? You don't think so? Oh, wait, yeah, times 4. It's going to be bigger than 91. Yes. All right, here we go. Let's see, watch this. I have to take a snapshot of the darkness and then paste it over it. That's the way I erase. So let's see, 91.125. I must have multiplied wrong or something. Multiply by 4 is 364.5. Weird. Divided by 3. Yeah, 121.5. Pi is the volume, and that is measured in inches cubed. And then you could get a decimal approximation of that as well if you want. So that is about 381 4.703 inches. 4.704. Right, so that's the volume of this particular soccer ball. I'll let you guys do the investigation as far as what standard size soccer ball that is. I also bought some soccer balls to send to kids in like Operation Christmas Child, like in a shoebox, and I had to deflate them and then also buy a bicycle pump to send it to them. It worked out okay, I think. So, surface area. Yeah, check this out. All right, I want volume. They gave me surface area. So I'm going to use two formulas here, gentlemen. Surface area is 4 pi r squared, and volume is 4/3 pi r cubed. And yeah, you guys are going to have these mesmerized for the test on Tuesday. The cheat sheet you get to have on the final, but I actually don't want to say that on the internet, because then what if future generations don't get a cheat sheet and they're like, Mr. Waddy, you gave your class last year, and I'll be like, forget you. What? Shh. They don't know. Shh. It's a code. They don't know. 324 pi. I'll just say the YouTube video was hacked by Russians or something, and then like, no, I didn't actually say that. They put that sound file in there. So let's see. Let's solve for R. Right, I'm going to need the R in order to find the volume, so that's why I'm bothering with this work over here. Plug in what I know, solve for what I don't. A classic algebra move. Divide both sides by 4 pi. And I'm going to flip it around here. R squared is going to equal, those pi's will cancel out, 324 divided by 4. That seems divisible. 81. Ooh. Oh, yes. Lovely. Here we go. R is going to equal plus or minus 9, but as a radius, we'll only take the positive version. R is equal to 9. And now I'll be able to take that and plug it in there, right? Is the plan. Let's see. 2 pi r. So volume is equal to 4/3 times pi times 9 squared. And so volume is equal to 4/3 times pi times 81. 81 is divisible by 3. 3 goes into 81 27 times. Oh! Error! Thank you. With the save. Man. Wow. Wow. Nice. 720. Nope. 9. Man. Come on, Mr. Waddy. I'm just nervous. It's like the last video, and I'm sad. Alright, 729 divided by 3 is 243. Multiply that by 4. I get 972 pi's. And that is my volume. If this was in square centimeters, the radius was measured in centimeters, and this is now measured in centimeters cubed. Right? And I'll multiply that by pi, in case you want it in decimal approximation. 3053.628 centimeters cubed. I think I'll call it a day for that. Thanks for watching, internet friends. Have a great day. Bye-bye.